Here's a strange fact about the smartest machines ever built. A frontier language model can pass the bar exam, write working code, and explain quantum field theory. But show it a cup sliding off a table and ask what happens next, and it is guessing. It has read every physics textbook on Earth. It has never seen anything fall. In 2026, the biggest names in AI are betting $3 billion that this, not scale, is the wall. This is the story of world models, and why the next leap in AI won't be a bigger LLM. For a decade, AI had one recipe. Take a transformer, feed it more text, make it bigger, and the recipe worked almost embarrassingly well. Each generation of models jumped in capability, from autocomplete to essays to code to reasoning that can win math Olympiads. The lesson everyone learned was simple: scale is all you need. But every recipe has ingredients, and this one is running out of the main one. Because under the hood, a language model does exactly one thing. Given a sequence of words, it predicts the next one. That's the whole game. Every essay, every proof, every conversation is that one move repeated. And here's the subtle part. To predict text well, the model must compress the patterns of everything we've ever written. That makes it a stunning model of human language. But language is a shadow of the world, not the world itself. The model learns the shadow, a map drawn from other maps. And in 2025, the cracks started to show. Frontier Labs found that high-quality training text is nearly exhausted. The internet, it turns out, is finite. Meanwhile, models that ace every benchmark still make mistakes no child would make. They misjudge whether a box can fit through a doorway. They lose track of objects that are briefly out of sight. And they hallucinate confidently, because predicting plausible words is not the same as knowing true things. Yann LeCun, one of the godfathers of deep learning, puts it bluntly. Today's best models, he argues, understand the physical world worse than a house cat. The cat can't talk, but the cat is running a physics engine in its head. That physics engine has a name. Cognitive scientists call it a world model. And you have one. Before you push a full cup across a table, something in your brain has already simulated the push, felt the slosh, and adjusted your grip. When you catch a ball, you are not solving equations. You are running a learned simulation of the world, forward in time, and acting on the prediction. You built that simulation as a baby, by watching, poking, and dropping things. Thousands of hours of unlabeled experience. No textbook. That is the kind of intelligence the next generation of AI is chasing. So how do you build one in silicon? Here's the blueprint most labs converge on. First, an encoder takes raw sensory input, video, sound, touch, and compresses it into a compact internal state. Not pixels, a representation of what matters: objects, positions, motion. Second, a dynamics model learns how that state changes over time and how actions push it around. Given the state now, and an action predict the state next. That single loop is the world model. Run it once and you get a prediction. Run it many times and you get imagination. Whole futures simulated before they happen. And notice what the model predicts. Not every pixel of the future, which is wasteful and mostly noise. It predicts in the compressed space of what matters. That idea, prediction in representation space, is the heart of architectures like JEPA, the Joint Embedding Predictive Architecture. If that sounds abstract, you may have already played with one. In early 2026, Google released Project Genie to the public. You type a sentence, and it generates an interactive world. Not a video, a place. You walk and the model dreams the path ahead of you, in real time, frame by frame. Push an object and it slides. Drop it and it falls. Nobody programmed that physics. The model learned it by watching video of our world the way a child watches. Each world lasts only about a minute before the dream loses coherence. But as a proof of concept, the message is loud. Neural networks can learn to simulate reality itself. Why does this change everything? Because a system that can imagine can plan. Give a robot a world model, and before it moves, it can test 1,000 grips in its head and execute only the one that works. Give an autonomous car a world model, and it can rehearse the rare disasters it has never lived through. Give a scientific AI a world model of proteins, or climate, or traffic, and experiments move from the lab into imagination, where they cost nothing and hurt no one. Even language agents need this. An assistant booking your travel is acting in a world of websites and consequences. When it can predict outcomes before clicking, mistakes stop being discoveries and start being simulations. Trial and error becomes trial without error. And the industry has noticed. In the first 6 months of 2026, investors poured over $3 billion into world model startups. Yann LeCun left Meta, after pioneering its AI lab, to found a company built entirely on this idea, and raised more than $1 billion before shipping a product. Fei-Fei Li, the scientist behind ImageNet, raised another $1 billion for World Labs to give AI spatial intelligence. DeepMind, NVIDIA, and OpenAI all have world model programs racing in parallel. When this many pioneers bet their reputations on the same idea, it doesn't guarantee they're right, but it tells you where the frontier believes the treasure is buried. Now, the honest counterargument. Some researchers think large language models are already learning world models, quietly, inside their weights. Train a model on Othello games, move by move, and probes find the board, encoded in its activations. It was never shown a board. Text was enough to force one into existence, so maybe the two camps are describing one road. Language models may keep absorbing the world structure from its descriptions, while world models learn it from raw experience, and the systems that win will do both. The debate isn't whether AI needs a model of the world, it's how the model gets built. So here's the idea to keep. Intelligence isn't a library of answers. It's a prediction engine for a world. For 70 years, we tried to give machines our knowledge. Then we gave them our words, all of them, and got something remarkable. The next step is stranger. We're giving them the world itself and letting them dream it forward. The next leap won't come from reading more. It'll come from watching, imagining, and predicting, the way you've done since before you could speak. If this kind of idea interests you, subscribe. Noesis explores one idea like this at a time. Thanks for watching.